Intel UHD Graphics. Intel UHD Graphics is the most common integrated GPU found inside everyday laptops and desktops. And here's something most people don't realize. Right now, it's probably running on more screens worldwide than any dedicated GPU ever made. So the way this works is instead of having a separate graphics card with its own chip and memory, Intel UHD Graphics is built directly inside the CPU. It doesn't have its own VRAM, so it borrows a portion of your system's RAM to store textures and frame data instead. Think of it like a small kitchen built into a studio apartment. It can cook a decent meal just fine, but it was never designed to cater a restaurant. It works perfectly for what the space was built for. For everyday tasks like browsing the web, watching YouTube videos, or moving windows around your desktop, Intel UHD handles all of that smoothly. The CPU sends instructions, the iGPU processes them, and the result shows up on your screen. But because it shares RAM with the rest of your system, memory bandwidth becomes a bottleneck. And in modern games or heavy 3D workloads, Intel UHD Graphics runs out of performance very quickly. That's why Intel UHD Graphics is best for students, office users, and basic home PCs. If you only need to browse, work, or stream, it's more than enough. But Intel knew this wasn't enough for everyone, and that's exactly why Iris Xe was born. Intel Iris Xe Graphics. Intel Iris Xe Graphics is Intel's significantly stronger integrated GPU, and when it launched in 2020, it was so much faster than what Intel had before that some reviewers actually thought the benchmark results were an error. What Iris Xe actually is a completely redesigned integrated GPU with far more execution units and a brand new architecture. It still lives inside the CPU and still shares system RAM, but the internal graphics engine is in a completely different league from standard UHD graphics. Think of it like upgrading from that studio apartment kitchen to a proper restaurant kitchen. Same building, more space, professional equipment. You can now actually cook for a crowd. For example, many esports titles like Valorant, CS2, and Fortnite can run smoothly on Iris Xe at the right settings. And video editing software can also use its hardware acceleration to speed up playback and exports. But there is still one clear limitation. Iris Xe depends heavily on RAM speed. If your laptop only has single-channel memory, performance can drop by nearly 30%. And it still cannot compete with a true dedicated GPU in heavy workloads. That's why Iris Xe is perfect for users who want a thin laptop that handles light gaming and content creation without needing a separate GPU. But if gaming performance is what actually matters to you, AMD had a completely different idea about how to solve that problem. AMD Vega Integrated Graphics. AMD Vega Integrated Graphics changed the conversation entirely. Because when the Ryzen 5 2400G launched in 2018, it outperformed Intel's integrated graphics by over 200%. That wasn't a small gap, that was embarrassing for Intel. What Vega integrated graphics actually are is a miniaturized version of AMD's Radeon GPU architecture built directly into Ryzen processors, which AMD calls APUs. These GPUs include multiple compute units that handle shading, geometry processing, and texture rendering in parallel. Think of Vega like a junior athlete who trained with the professional team. They're not playing in the championship yet, but they're running the same drills, using the same playbook, and performing way above what anyone expected from someone at that level. For example, popular games like GTA 5, Rocket League, and Dota 2 can run surprisingly well on Vega integrated graphics, especially when paired with fast dual-channel RAM. But there is still a clear limitation. Because Vega uses shared system memory, performance scales heavily with RAM speed. Slow RAM can cut its performance almost in half, and it still struggles with modern AAA games that demand large dedicated VRAM. That's why Vega became the go-to choice for budget gaming PCs and compact desktops where a dedicated GPU doesn't fit the budget. But AMD wasn't done, because everything Vega proved was just the foundation for something far more powerful. RDNA Integrated Graphics. RDNA Integrated Graphics didn't just improve on Vega, they completely replaced the architecture. and the Radeon 780M inside the Ryzen Z Extreme is now powerful enough to run Cyberpunk 2077 at playable frame rates from an integrated GPU inside a handheld device. What RDNA integrated graphics actually are is AMD's modern desktop and laptop GPU architecture shrunk down to fit inside a CPU. The same compute units found in standalone Radeon graphics cards are now running integrated inside the processor. Imagine taking the blueprint of a full concert hall and scaling it down to fit inside a single room without removing a single seat. Everything still works, every acoustic detail is preserved, just compressed into a smaller space. For example, integrated GPUs like the Radeon 680M and 780M can run many modern games at 1080p with reasonable settings. Just a few years ago, that sentence would have sounded like a joke when talking about integrated graphics. But the main limitation remains shared memory. Even with a powerful architecture, heavy textures and large open-world environments can still saturate system RAM bandwidth before the GPU runs out of processing power. That's why RDNA graphics are ideal for thin gaming laptops, handheld gaming devices, and compact desktops. But while AMD was pushing integrated graphics to the limit, Apple was solving the memory problem in a completely different way. Apple Integrated GPU. Apple Integrated GPUs are built into Apple Silicon processors like the M1 series chips, and the M1 Ultra's integrated GPU is powerful enough to beat a dedicated NVIDIA RTX 3090 in certain creative workloads from a chip that uses a fraction of the power. What makes Apple's approach completely different is the unified memory architecture. Instead of the CPU and GPU having separate memory pools that need to constantly transfer data between them, both share the exact same high-speed memory simultaneously. Think of traditional GPU memory like two cities connected by a bridge. Data has to cross that bridge every single time. Apple's design removes the bridge entirely and puts everything in the same city. No crossing, no delay, no traffic. Because of this, Apple integrated GPUs deliver genuinely strong performance in video editing, 3D rendering, and machine learning tasks. Final Cut Pro can edit multiple streams of 8K footage on an M-series chip that a traditional laptop would completely choke on. But the limitation is the ecosystem. Most PC games and Windows applications are built around traditional GPU architectures and never optimized for Apple Silicon. So raw performance numbers don't always translate into real-world usability outside Apple's software world. That's why Apple integrated GPUs are unbeatable for creators locked into Apple's ecosystem. But what about systems that don't want to choose between integrated and dedicated and want both running at the same time? Hybrid graphics. Hybrid graphics is a system where a laptop uses both an integrated GPU and a dedicated graphics card simultaneously. And most people who own a gaming laptop right now are using this system without even knowing it. So what hybrid graphics actually is an intelligent switching system. The integrated GPU handles light tasks like browsing, watching videos, or using office software. The moment a demanding application launches, the system automatically hands the workload to the dedicated GPU instead. So here's how it works in practice. When you open a heavy game, the system detects that more power is needed. Technologies like NVIDIA Optimus or AMD SmartShift transfer the workload to the dedicated GPU, while the integrated GPU keeps managing the display and background tasks. Think of it like a building with its own solar panels and a connection to the main power grid. During the day, the solar panels handle everything, quietly and cheaply. When demand spikes, the grid kicks in, automatically. You don't flip a switch, it just happens. And the biggest advantage is battery life. Because the powerful dedicated GPU only activates when you actually need it, gaming laptops running hybrid graphics can last 4 to 6 hours on basic tasks, something that was nearly impossible in older always-on GPU designs. But there are performance trade-offs. In certain setups, the integrated GPU creates a slight bottleneck because the final frame still passes through it before reaching your screen. That's why some competitive gamers disable the iGPU entirely and run the dedicated GPU in direct output mode for maximum frame rates. That's why hybrid graphics is the default design in almost every modern gaming and creator laptop. It's the best compromise between raw power and real-world usability. And understanding how it works explains why your laptop behaves so differently plugged in versus on battery. And this is why understanding integrated graphics matters so much. Whether it's Intel UHD, Iris Xe, AMD Vega, RDNA graphics, Apple's unified GPU, or a full hybrid GPU system, each design is built for a different level of performance and a different kind of user. Some are built for simple everyday tasks, while others are powerful enough to handle light gaming, creative workloads, or even run side by side with a dedicated card. Subscribe if you enjoy simple explanations that make complex tech easier to understand.